it's annoying that when you try to recreate a bug and it doesn't show up and you can't do the screen grab and report it to the company. But obviously, we don't have to use any of this footage that we don't want to, or we can put up. Benjamin, when I told him that you might prefer a static image, he immediately went off the deep end. He's like, cool, so we'll do it AI. We'll have Bryan shirtless fighting a minotaur.
Hold on, not photorealistic, very Grecian portrait type of stuff that you see in the Louvre, it'd be very tasteful. It'd be like really wrestling it down. Or I also had the idea of making you a Vulcan Civil War general. I think that'd be nice.
That is a deep cut. That is a deep cut. Are we talking first Vulcan Civil War? Are we talking like the Enterprise, like
I don't know. I thought about the Vulcan Civil War because I actually know about that, but then I also thought it's like an American Civil War general with really cool pointy ears,
just Vulcan ears,
just no emotion, Vulcan ears, and like ridiculous epaulets.
Speaking of Zoom backgrounds, I knew a philosophy student who used a Zoom background of their actual background, but with like slight changes so that people would have a justified true belief that wasn't knowledge, since the background would actually be their background, but it would be a image of their background, but not their background.
That's ridiculous.
Yeah.
That was so deep that I fell in.
That's ridiculous.
Yeah.
Faking a background that doesn't need it at all. I freaking love that. That's great.
I think during COVID times, I would do that classical prank of like recording myself with my regular background, wearing the same T-shirt, and then play that as a video Zoom background, and then every so often just like slightly shift to the side and watch like one or two people on the call freak out that there was suddenly two of me.
Yeah, I like that. I mean, I would just have you just like walking through the background occasionally behind you. I guess you kind of have to have a chair like this so that you don't have to do some sophisticated like superimposing yourself in the original video. You just record this chair and then sit in it.
Oh, that's good.
Okay, cool.
That's good. I want to jump right in and welcome everyone to this episode of Science Actually Presents the Nerd and the Scientist. And today we are joined by a dear friend of the show, Bryan Scott, joining us from the Windy City, which I think you were the one to teach me that it was not named as such because it is meteorologically windy, but because the Chicagans at the World's Fair were known to be full of hot air. Is that?
I mean, I've also heard that it's because the politicians like to blow hot air. So.
Yes, I've heard the politician one.
Well, Bryan, thank you for joining us. I'm so excited. I mean, you and myself and Benjamin had the pleasure of hanging out in person a few years ago. I mean, you and myself obviously have hung out quite a few times through the Data Science Fellowship Program, which we'll hopefully get to. But welcome to the show, and thank you for joining us.
Yeah, it's good to be here. Really appreciate the offer to join.
Welcome.
Now, there are a few things I wanted to chat about, but I feel like what's going to be really the overarching theme is this idea of non-traditional journeys. I think that we've realized with all the guests that we've had who are in the sciences or have a background in the sciences that there's no real such thing as a traditional path through academia, through life, through research. So maybe to get started, do you want to tell us how you found yourself falling into the world of astrophysics to begin with?
Yeah, I mean, I can just give the little career narrative. I mean,
sure.
The honest answer is I grew up watching Star Trek, and so it was kind of preordained that I'd end up being an astrophysicist. But I went to it's a fairly well-known engineering college in California for my undergrad, but not as well-known outside, I think, of the West Coast. It was Cal Poly San Luis Obispo, which was really influential on me. It's a polytechnic university, which means different things in different parts of the world. But in the U.S., it's kind of a name for a kind of unique kind of college that is very hands-on. So a lot of the coursework was put people in a lab with equipment and no instructions and say, replicate this experiment that, won a Nobel Prize 50 years ago. And this is, I think it's an incredibly formative way of educating people, because you are grappling with science in a real, practical, physical way. And it's also teaching you how to learn in a different way than like seeing how some textbook describes a problem. It's really teaching you this kind of applied problem solving skills. This was really influential on me. And I think kind of changed a lot about how I thought about the next steps in my career. So when I graduated, I went to the NASA Jet Propulsion Laboratory in Southern California. And I actually switched gears. We can talk more about this. But I switched from doing observational astrophysics to doing planetary science mission design, primarily for the Europa Clipper and NASA Psyche missions, both of which are now in flight. So that's really exciting, 10 years later to see the hard work pay off. And then I went to the University of California, Riverside for my PhD, originally intending to do the kind of observational astrophysics work that I had done as an undergrad. But I switched gears partway through to doing more astrostatistics, statistical cosmology, which is what I ended up kind of setting the longer term trajectory. But I think that wasn't the most kind of influential impact that UCR had. It was kind of the background for my scientific development. But UCR was really influential in teaching me to think more broadly about the social impact. And that's really kind of, when you're on the campus, you really see this. It's one of the most diverse major research universities in the US, and it's one of the few institutions to have equal outcomes for students kind of independent of their backgrounds. And so being in that environment, being exposed to leading scholarship in the humanities, in the social sciences, teaching, these really sort of set the kind of values for the rest of my career.
I love that. The true values of Star Trek as well.
Yeah. In retrospect, it all kind of makes sense. I'll pretend that it was that well planned for sure.
Sure. Yeah. You worked at JPL and got two things launched on the way to finishing your academic career. And that's very Star Trek, because you watch the shows and all the kids are growing up working on these probes that go out and get launched, and they live on starships and while they're going on missions and being kids. Same thing.
Yeah. I mean, it is. It's an incredibly surreal. Really is. I think surreal is the only word that can describe. When you watch the launch of something that you worked on. I'm not going to say I had a tremendous role in shaping what these missions ultimately looked like, but having any sort of role. And this was one of my favorite things about JPL is the JPL director at the time, Charles Alachi, used to, when there was a mission launch, he would pay particular attention to calling out the contributions of the administrative staff, the janitors, the security people, as all having a role, and trying to remind people that they should take pride in the fact that they, even if you are, anybody from an engineer to a janitor, has this impact on the discovery process, and that it wouldn't be possible without everybody that touched it in any way. And I think that was also, it was a small thing, but I think it also sort of set a core value for the rest of my career to sort of hear that right out of my undergraduate, to see those values modeled from the top of, essentially the top of NASA leadership in particular.
That's wonderful.
I love that. Yeah. Like the idea of some people seeing support staff as being basically extras, rather than actually recognizing that, like, it's not support as in, oh, it's nice to have. It's support as in, this is a critical part of the foundation of any organization or project. It's so cool. I'm curious what, at least from my perspective, I see a lot of the work that you've done, both, through the program that we met and also the stuff that you do in terms of helping students for career advice, getting into colleges, etc. How did you find yourself driven to focus on helping students in that way?
Yeah, I mean, I think I alluded to this, but I think being at UC Riverside, and especially being in so for people that may not be aware, in physics, PhDs are sort of paid for, but you have to typically do labor as part of to pay for your degree. So what that looks like in practice is either you receive a research fellowship, typically if that, so you might receive a research fellowship, which might be from like a named award from a national lab or a government agency, or a kind of assistantship, which is your advisor or the institution paying you to do research. And that's, for a lot of PhD students, that's really the goal, is to get those research assistantships, because then they're not distracted and they're able to focus on their research project, which is how you sort of set yourself up for success in your research career and ultimately become a faculty member or something like that. Most of my time at UCR was paid for with teaching assistantships. So that's going into classrooms and teaching. And I think especially when you're teaching in an environment where there is such a range of experiences that students are bringing into the classroom, and you're surrounded in this culture of really supporting student success, I think it just changes how you think about your career. And I don't know anybody who went through there that wasn't changed in some way by this very teaching and socially driven kind of institution. But it was just very influential on me. So I realized about maybe 3/4 of the way through that, I sort of went in wanting to do research for its own sake. And I wasn't really intent on a research career to begin with. But I realized about 3/4 of the way through that A, I enjoyed research, and B, I really, really enjoyed teaching. And so the goal for the next step was to find a role that combines all of these influences, the ability to do some research, but really to try and shape the next generation, and to give back to the broader community that allowed me to pursue the science that I was doing in my PhD.
Love that.
You earned a lot of certificates at UC Riverside
Yeah.
for teaching excellence and inclusiveness and everything. And it just shows that
Yeah,
you're not just saying words here. You really love the teaching.
Yeah, I mean, people used to a lot of one of the administrative staff at UCR thought it was the most amusing thing that I would volunteer, especially to teach the pre-med students. I absolutely loved the pre-med classes, and I was the only one that would volunteer to sign up for those classes because most people are looking for to teach the physics students or the engineering students. I mean, let me just put it this way. It's a unique experience teaching pre-med students. That really became my passion. And I think everyone around me thought it was bizarre and inexplicable.
What's the big deal about teaching med students physics?
They're not as they don't come in as intrinsically motivated to study physics as a physics student, I think is probably the nice way to put it. The more complicated answer is that they're under a lot of external pressure, and a lot of the kind of socialization around medicine and biology and chemistry is very different from the socialization that they receive in a physics classroom. And so that's partly why I enjoyed it so much. Is it was an opportunity to shape their understanding of the discipline in a way that allowed me to sort of emphasize the contrast with other disciplines, and also to learn about what those other disciplines are like. I think especially among physicists, and I would say more so early career physicists than late career physicists, but there is this attitude that physics is kind of uniquely difficult, that it plays by different rules, these sorts of things. And that exposure to how those students were learning their disciplines, I think, was also really influential on allowing me to have a deeper appreciation for other fields.
So, what's your number one go-to trick to getting people who are not attuned to the physics world to enjoy learning about the physics world?
Wow. I think there is no secret. There is no secret. I think the joke, but it's true, is the difference between, people who get PhDs in physics and people who don't is really just pain tolerance. And I would just say, really just stick with it, because the reward, the journey is the reward, right? So it's about puzzle solving. It's about sticking with a difficult problem until you get it, and that payoff is huge. And it's one thing I worry about with, I think we might talk about AI a little later, but this is one thing that I worry about with LLMs and introductory physics classrooms, is that what you're learning when you learn to solve an introductory physics problem, you're learning important kind of problem solving strategies that you'll you'll apply to other problems, but what you're also learning is about that process of sitting with a certain kind of reasoning and a certain kind of experience that's difficult. And if you don't do that yourself, you're never going to get that enjoyment out of it. You can copy down the answer, but that's not the point. It's not the point for your learning, but it's also not the point for your experience of whatever it is that you're studying. The study itself should give you something meaningful, some sort of fulfillment. And I mean, this is going to be true of every discipline, but I think a certain kind of physics problems are really what I think about. Potentially a generation of students missing out on having that kind of experience and gaining that kind of cultural insight that really shapes how professional science works.
Right. I guess there's a difference between the act of problem solving and the act of finding a solution, right, or obtaining a solution. Definitely.
Yeah. And it's a hard thing. I mean, to go back, right, this is one of the things that life sciences students struggle with, because they're taught that they've been rewarded so much for obtaining a solution, not the process of finding a solution or solving an unsolved problem. And so when they're introduced for the first time to a problem that where they can't just easily obtain the solution, it creates a lot of emotional challenge for them. It's a new emotional experience more than it is a new technical or academic experience for them.
So I guess since you brought up the, I'll try to put two segues in one, since we're talking about AI and you're also talking about the pain tolerance threshold that's needed to do a PhD and enjoying the experience. So one of the things that's made my PhD, which is hopefully weeks away from ending, is the experience that I had as a fellow of the LSST DA Data Science Fellowship Program, which is where we met. You were one of the people running the program. And it was an incredibly enjoyable and also rewarding part of my PhD experience, being able to travel to the US and participate in these workshops. And I think that to touch on both of those previous points of problem solving and also AI, it was extremely beneficial that these workshops were always structured in a way of kind of listen to some new content, try your hand at it, and then move on to the next bit. Rather, there was never a focus on the solutions or getting the answers and ticking a box, which was especially interesting when it came to the workshops that were in particular focused on AI and that implementation.
Yeah. I mean, I was going to say, I think it's something we struggled with a little bit in terms of should there be an assessment piece. This was something that we had long conversations about. I think it certainly, I guess, to back up a little bit and provide some context, right? These were, the LSST, DA, DSFP, lots of letters. We also struggled for a while figuring out how to get that on a sweatshirt in a legible way. Is a program that's meant to take astrophysics PhD students, and especially for the first 7-8 years of the program's history, really thinking very broadly about people from theory backgrounds to laboratory experimentalists, and provide them a very in-depth but very rapid education in modern statistical methods to prepare them for big data. And I think it's also worth saying for people that maybe aren't familiar with some of the jargon, right, is AI has sort of changed, the meaning of the term has changed. So people use AI to describe a lot of different technologies, everything from large language models to what typically in science we thought of as AI or something like AI, which is more like machine learning models where you're sort of fitting sometimes very explicit parameterization to some problem, or you might be have something that's more of a black box model that takes kind of data and it learns patterns and then tells scientists about important patterns. So there's been a big change, right? So even within that space, what kinds of models people think about, all of this has really evolved rapidly over the last couple of years, in particular, as it has for the rest of society. But so we were really focused on providing that foundation in these kinds of more machine learning methods. And certainly now, I think going forward, I'm sure the program will focus on, contemporary technologies, new technologies as they evolve. but allowing people in the community to take advantage of these very large next generation data sets. But I think also educating this next generation in this more interdisciplinary and leadership oriented way. And sort of saying that there aren't these hard and fast disciplinary boundaries, that these technologies and this data driven approach to science means that we're going to need theorists who are doing black hole simulations to talk to observers and to talk to experimentalists who are doing things in the lab, in order to be able to pose the questions that the quality and scale of the data combined with these algorithms will allow them to ask and answer. So that was kind of the background of the program. To your question, right? So that assessment piece, right? So in pedagogical theory, there's this important role that assessment plays because people need sort of feedback in order to learn, right? So that was something that we had a lot of long conversations about. To what extent would we include assessment in the program, versus how much did we want it to be this very like open-ended thing, right? And I think what we settled on was kind of a mix somewhere in the middle, where the assessment piece is meant to be very instructor and group centered. So you get feedback from the instructor in the room, but also feedback through your relationships with your peers. And the hope was really that by pairing people up, having them work on problems together, people who maybe didn't hang out during the lunches together, that could create new opportunities for people to learn from each other, and learn from the unique styles that other people, and as an international program, even people from, very different cultural backgrounds, very different educational systems, to really include that peer mentorship and that peer leadership component. And there were some other ways that we did that as well. We can definitely talk more about how the program was really structured from the beginning to facilitate that kind of mentorship as a way of both teaching leadership and providing that feedback part for the sort of learning cycle.
Wow. I am a huge fan of data visualization. It's Kovi knows. This is for me a beautiful Sunday afternoon is gathering a data set and staring at a spreadsheet for a long time and then trying to find patterns and see how I can represent it visually or graphically, because it's just a lot of fun. Makes no sense, but that's just how I am. I guess you appreciate that. I guess this is our people. What exactly is data ethics? I've seen that in my reading about the things that you do and try to organize. And how do you explain what that is? Because the data sets that you are working with the physics and astrophysics is massively huger than me wondering who had the most home runs. But how do you explain that down to somebody at my level, which is down here?
Yeah, I think this is a good question, right? I think a lot of people have heard about, and these are core issues and things that we talked about, but things like algorithmic transparency, bias, fairness, making sure that especially in industry models, that models are treating people fairly and equitably is an important ethical consideration. In astrophysics, I think people sometimes don't see the clear link between ethics and we have data on galactic structure or high energy, the number of gamma ray bursts or something, right? And so I think the main issue that I think came up here and really is posed by a lot of these next generation data sets really has to do with access and the structure of the community. So I think people sometimes miss. I think people rightly get very worried about what the algorithms are doing, and I think there's a lot of important work to be done there. I don't want to minimize that at all, but I think it's easier to miss that even the act of saying that you have data, or who gets the data, who has access to the resources, raises sort of structural ethical questions. And I'll give an example of this that is came up during my PhD and is still an active issue in the community, which is the construction of the 30-meter telescope, which is on Mauna Kea in Hawaii, which is a sacred site to the Native Hawaiian people. And there's many many issues around that act of building a large industrial facility to do astronomy, right? And I think a lot of astronomers, I will say, I think, I'm not going to say a lot of astronomers, I think every astronomer I've ever talked to believes that astronomy is a benefit to humanity and believes that constructing observatories and doing observations is, many astronomers are driven by deep moral commitments, believing that this is a good thing. I think so. I think there are a lot of issues around the site, and there's a lot of issues around the process, and there's a lot of there's a very real question about whether that should be done at all. But I think one issue that I have thought a lot about is the fact that there is a very narrow pathway that very few people have walked if you are a native Hawaiian to becoming a professional astronomer who could have access to that observatory. And so I think that's also a data ethics issue, not in terms of the data itself, but the data generating process. That I think, certainly the community, society at large, really benefits from spending more time thinking deeply about. So that's just one example of an issue that I think, maybe doesn't come up as often, or I shouldn't say come up as often, but doesn't get called explicitly an ethics issue enough.
Mm-hmm.
Got it.
That makes sense.
There's a lot of mention of using AI and everything to help work their way through patterns and stuff in the data. Is there an issue with AI slop in that in that realm of AI, as there is like in online, all the horrible images that people are pumping out with AI, which is considered AI slop, and the horrible AI slop videos and just all that nonsense? Is there a similar issue with like? Well, that's a serious question. We have all this data.
That's a good question.
We have all this data, but are we sure that the AI that's helping you find patterns in the data is finding the right patterns?
No. I mean, no. I mean, that was, in big part, why the DSFP existed, is to try and educate students and in the methodologies to check the outputs, right? To understand what the output is really telling you and what the limitations are. I mean, I think the broader question is, and especially with large language models or related models or derivative models, and there's some very fascinating, very sophisticated techniques for taking astrophysics data and feeding it through these kinds of large language models to get them to do science with data that looks very different from what they were trained on. And so I will say, I think there's a lot, a very broad and very serious awareness in the community of these kinds of things like hallucinations and the danger that poses for these kinds of models in science. There's also a lot of very sophisticated work being done to, create cycles and processes where these models either get checked by humans or have internal consistency checks, and really trying to integrate them into the overall scientific process. And I guess maybe the deeper point as I'm saying that is that this is how science has always worked, is there's lots of humans who generate human slop. And that sounds derogatory, but yeah, as a scientist,
that makes sense.
I think there's lots of the raw material of science is bad ideas, right? It's not about bad ideas. It's the important thing is that you check those bad ideas. And so a lot of the work around AI and science is, can we take what we know about the scientific process and integrate AI-driven workflows into the scientific process to make AI more scientifically grounded, or an appropriate tool for doing science. I mean, I was going to say, what would certainly be a bad idea is going to Gemini, typing in, write me this paper, and then sending it to your colleagues. There are many documented cases of that happening also.
And this is the point I was going to raise. Like the archive, which is a preprint server where people put up their scientific manuscripts to share them with the community. In some cases before they're published by a journal, an academic journal, in some cases after. They've recently had to change their policy about a month ago, just because they were the sheer volume of AI papers that were entirely AI written that was coming in just made it kind of unbearable for the existing infrastructure to deal with and to triage. And so their new policy is something like, if this is clearly AI slop, if there's a bunch of hallucinated stuff in here, or like you've left remnants of the prompt or the AI response of here, sure, here's an answer for you. They will ban you for a year from uploading to the archive,
Good.
which is
yeah. I might go with a lifetime ban there.
but yeah, like I think you're saying rightly so, that there's an appropriate way to use AI to optimize your workflows, to kind of improve your productivity and allow us to go from, to use it as a tool, right? Like this was the thing with the invention of writing. You know, people were opposed to it, this idea of, oh, if we store information in these little book things or scrolls, then people are going to forget how to remember things by themselves. It's like, okay, well that didn't quite happen, but you know, there's a way that we can better humanity by using this new technology. We just have to avoid using it badly.
Yeah. I mean, I think broadly speaking, it's and I think this is someplace where sometimes the public discourse gets a little bit off track, is missing that there are good uses of the technology too, and there are very serious people who are thinking very deeply about how these can be used for positive ends. I think it's hard to say how much of the kind of lesser uses, you know, what the ratio of people using this in sort of, you know, to just generate papers to put them on the archive because the metric, you know, and I think part of this is also reflecting problems with the metrics for career success that have existed in the past, like number of papers published is kind of, it's a, you know, I always thought that as a metric of career success, or the pace at which you publish as a measure of career success, was always incentivizing the kinds of, you know, not necessarily always to bad end, but often incentivizing not sitting deeply with a problem, not really trying to be careful or really, you know, find the best solution, because there were lots of incentives to just get stuff out quickly. So I think what you see with people having AIs write their papers is really reflecting that older kind of metric. I think, unfortunately, one of the unintended consequences of these tools, though, is that it does increase the rate at which people are going to be able to publish. And so if that continues to be one of the metrics, even when you're talking about work that people are doing themselves and writing themselves, the pace is going to increase dramatically. And it really becomes a signal to noise problem of how do you select the papers that are going to be the best insights that will lead you to new discoveries. So at an individual level, right? So I think I think maybe the broader point here is that there's a difference between the pace of discovery and the pace of reporting discoveries, where maybe not every discovery that's reported is a genuine discovery. And the danger is that former, no matter how those results are generated, whether they're AI driven or AI written, right? But if that overwhelms the pace of genuine discovery or the genuine discovery process, that it just makes everybody's job much more difficult, and it makes it much harder to see where the new insights are going to come from.
Yeah, that's tricky.
I never thought I'd see that as making everyone else's work harder.
Yeah, I mean the flip side is that, you know, I'll also say it's like having studied at an institution that is still a major research university, but kind of a little bit outside the sort of main pathways that the research community kind of funnels through. You know, the flip side is that it also makes it much easier to do, you know, to find papers and to learn things about the culture of the field. You can ask questions and have access to that if you're not, you know, in the leading department in your field. You can learn a lot about other fields that in the past would require you, for example, to travel to a different institution or to have a friend in a different institution. And so it's part of this overall, you know, in a very positive way, it's part of this overall, you know, process of making the world smaller and more connected. But it does obviously have these costs, which in some cases are genuinely new, and in other cases are just kind of continuations of problems that already existed.
Right.
I love that.
Benjamin's just nodding aggressively in agreement. Yeah.
No, because you hear about AI and people using AI to do their work, and like we just talked about archive, people are pushing things that are clearly AI created, and it's there's a penalty if you're busted for it and so on, and I see how that would hinder your working, but I never really thought about you're putting AI driven stuff up there that you clearly didn't do, and that's and as I can't find my words. And as a side effect of that, it's making other people who are doing genuine work, it's making their work harder. So I never thought about the other side of that. Because
Yeah, I mean, a lot of I'd say probably 70 to 80% of what a PhD is it's just learning learning which papers to read and which ones to skip. And when somebody's adding a bunch of noise on top of that, yeah, I mean, and I think that's another thing that people have talked about how you know uh, especially recently, there's been some really impressive mathematical results that the LLMs have generated um, when somebody just knows how to ask them the right question, which is a really fascinating thing, right? And it seems like the pattern there is that if somebody knows how to ask the right question, they're really good at piecing together results that collectively lead to an answer that a human could have seen all of these different things and fairly straightforwardly piece them together into a impressive and novel proof. Um, and I think that's fascinating. I think it speaks to how these sort of the underlying technology. Um, but the one thing that people have highlighted for PhD students in particular is that that's essentially the task that PhD students are given in the first 2-3 years of a PhD is learn how to take bits and pieces of other things and put them together to get your first result.
Yeah.
And that's meant to build up that skill of knowing how to identify relevant papers, right? So I think there's multiple things that are making, I think, especially PhD level education, going to change in a really dramatic way if the kind of easy, I don't want to call them easy problems, but I would say these kinds of more synthesis as opposed to generative kind of problems that early PhD and master students are given as part of their training, if those become, very much easier to do, again, it's sort of, as we were talking about earlier, it shortcuts the process. And the point of a PhD is the process of doing a PhD, not the papers that it generates. Those are kind of a bonus on top. So you add in the fact that you're adding noise, making the actual task for the human to pick out what's important, more difficult, and you remove the credit mechanism for synthesizing results by having AIs just pick off all the low hanging fruit. I think PhD education, maybe in the end, will be more affected than undergraduate education by what these models are able to do.
Oof. Maybe transitioning from these hard questions, which I think we'll certainly be thinking about, I guess, as a society over the coming years. We have a rapid fire round of questions for you that we'd like to finish off each episode with. I know that there's a lot that we didn't get a chance to talk about yet, so we'll have to have you back on to talk more about your research and your current role.
Yes,
but
please.
Are you ready for questions and quibbles?
Sure. Yeah. Let's do it.
It's a nice round prime number of questions. All right. First question. What is the weirdest thing you believed as a kid?
Wow. I don't even. I think all my beliefs I actually think all my beliefs have always been very sensible. I'll have to take a rain check on that one. I have no idea.
We'll hold you to that for the next episode. We'll give you 12 questions next time.
Yeah. What is one scientific discovery you wish you could have witnessed in person?
Oh, wow. So there was a experiment that was done, but I used to have my students kind of think through the implications of this. So there was one of the earliest female physicists whose name I struggle to pronounce because it's French, but Emily du Châtelet. Maybe one of you knows the correct pronunciation. But she dropped these basically balls into kind of a clay or a sticky material and measured the depth. And she used this experiment to prove basically the conservation of energy, which Newton and Leibniz and everyone else had completely missed as an additional conserved quantity. And history doesn't remember her as one of the great early physicists because of her gender, but I think it's a incredibly important story in the history of science. I think there's a lot of details around it that emphasize how science actually works, the social dimensions of science. So there are lots of other discoveries that I would love to have been present for, but I think that is a incredibly important and often missed moment in physics, and so it's something that I like to share as often as I can. That I used to share with my students, and help them to understand science as a process in the social dimension as well.
Nice. We should try to link to that in the show notes if there's a nice description article.
And yeah.
Maybe a different historical scientist. If you had to pick one historical scientist to go bowling with, who would it be?
Oh, I mean, this is an obvious answer, but I would love to meet Einstein. I think he was probably a great bowler, judging from his haircut. So, and it's one of those stories that no one would believe, right? It's like, yeah, I met Einstein at a bowling alley. No one's going to believe that.
It's like Bill Murray stealing French fries.
That's exactly what I was thinking about.
Bill Murray is a treasure. Like a brand new American folk hero. I love it. And I can see Einstein do the exact same thing. If you were a sandwich, what kind of sandwich would you be?
Oh, so I'm a vegetarian, so it would have to be some sort of vegetable sandwich, since you are what you eat.
Ooh. How have we? Okay, so everybody answers that question.
He's getting it. He's getting.
No, it's perfect. Everybody answers that question of like, not what sandwich would you be, but what sandwich do you like to eat? What's your favorite sandwich to eat? Which is a fair way to assess a ridiculous question. Right. But that's the first time we got an answer that actually brought those two together. You are what you eat. I love that.
I'm still waiting for that self-preservation. I'd be a noxious, poisonous sandwich you wouldn't want to touch. That I wouldn't be eating. But this is good. This is awesome.
I mean, I've always assumed, and maybe this is wrong, but I've always assumed it's a Hitchhiker's Guide to the Galaxy sort of a situation where if you don't eat a sandwich, you're depriving it of its highest goal in life.
Yeah,
that is awesome. So along those lines, really quick, what is your favorite sandwich? Since you found your way through the gauntlet of this question, what is your favorite sandwich?
At the moment, there's a new egg salad. It's kind of like a Korean egg salad sandwich place or Japanese Asian egg salad sandwich place down the street from me that I'm pretty obsessed with. So at the moment, I think that's my answer.
I love a good egg salad sandwich. That's an excellent sandwich. Okay.
Question 6. What is your most controversial opinion about pizza?
I mean, I don't think it's controversial, but I'm really proud of the fact that pizza was invented in Chicago.
Can we get a sideline to that answer? And really quickly, if this is possible, if it's possible as a Chicagoan, what's your take on deep dish? Is that a pizza? Is that an embarrassment? Is it delicious? Is it eh?
Is there another kind of pizza? I'm not familiar with.
We're going to get demonetized.
I love deep dish. I do love a good deep dish, but there are some people who are haters who just call it soup in a bread bowl. And
I mean, I think there's a real distinction between if you've had the good stuff or if you've had the chain deep dish stuff. So I, come to Chicago, I'll take you to the good places.
Okay. What is your favorite scientific word or phrase?
So that's a good one. I mean, I think it's a good question. I think it's I mean, spaghettification, I think, is probably a favorite for a lot of people. So yeah, I think that's always the one that comes to mind for me.
Nice.
It's a good one.
What would you say is your least favorite scientific word or phrase?
Well, that's also a good question. Um, yeah, I mean, I think like let's see, what is it like? Um, Jansky's per stir radian per second or something. There's some crazy units out there. Yeah, I mean, like a classic one is like kilowatt hour. It's like, yeah, I don't like any. Oh, it's Jansky's per stir radian per hertz. I think is the one that I don't like the most, because you can end up with a hertz times seconds that comes out of that.
Oh dear Lord.
Yeah.
Yeah. Flux units.
Yeah.
Okay. What is your favorite useless science fact?
That's also a good question. I mean, I'll just share my favorite science fact. It happens to be useless, but it is my favorite, which is the observable universe is 96 billion light years across, but the universe is only 13 billion and some change years old. And I'll let folks stew on how that one is possible, but I
stew on that regularly. I still don't get it, and I love it.
Yeah.
I'm not sure whether we'll get more angry letters from that or from the pizza comment, but we'll see.
I don't see how anyone could object to my views on pizza and its origin.
All right. If you could rename one planet in our solar system, what would you call it?
George. So Uranus's original name was George, and I think they should have stuck with it.
Nice.
Yes! There's a lot of connection going on here with you and me, man. This is great. I love the ambience behind you. I love all the things we like the same things, and I love that fact. That's one of my favorite things.
Amazing.
Okay, last one. If you had to sing one karaoke song to save humanity from an alien invasion, what would it be?
Empire State of Mind.
Oh.
Yeah, I once saw some very high profile, very famous astrophysicists doing Empire State of Mind as karaoke on a boat in Tokyo Bay. So that was one of the most surreal moments of my life.
Amazing. Bryan, you have run the gauntlet, and we are very, very appreciative of your time, but we will have to get you back on another time to talk about your research, that you have an amazing science paper coming up, but also about your current work in a future episode. For now, is there anywhere where people can find you on the interwebs, or you mostly staying off the socials?
Mostly staying off the socials, but I do have a GitHub page. You can put it in the show notes, and people should feel free to reach out. I'm always happy to make new connections, chat with people about interesting problems. So yeah, you can find all my contact info there.
Amazing. Benjamin, do you want to remind people where they can find you and other episodes of our show?
Yes, you can find me under Science Actually on the Facebook and on the Instagram and all the other I don't know which ones are the good ones anymore, but they're all out there. Get your daily science fact, get your daily collective noun of animals, which is for some reason popular. And you can also find this show wherever you get your podcasts, which you've clearly figured out now because you're listening to it. And if you'd like to see us making the sounds that you're hearing, you can find us on YouTube and on TikTok. And Kovi, where are you?
Folks can find me at Fun Fact Science on all the places that Benjamin just mentioned. And we will see you all next time on the next episode of Science Actually Presents The Nerd and the Scientist.
Oh, and please hit the like buttons and hit the subscribe
Oh,
buttons and hit
yes. Like and subscribe.
and
All,
the
do
share
all the
button
things.
and leave us comments and ratings. Yeah, you don't have to give us all the stars, but the more you give us, the more chance you have of having better luck today. So I mean, seriously, that's true.